Hello students, today I talk about new topic B.Sc.1st theorems. To find the Q root, to find the Q root roots of cos theta plus iota sin theta to the power whole of p by q, where p by q is the its lowest terms then cos theta plus iota sin theta whole to the power p by q is cos p by q theta iota plus sin p by q theta. We know that the cosine and sine of an angle have the same values when the angle is increased by any integral multiple of 2 pi, then cos theta plus iota sin theta whole to the power p by q is equal to cos theta can be theta plus 2k pi plus iota sin theta plus 2k pi to the power p by q, then cos p by q theta plus 2k pi plus iota sin p by q theta plus 2k pi, where k is equal to 0, 1, 2. The q different value of different values of cos theta plus I sin theta p by q 1 for k is equal to 0, 1, 2, q minus 1 in the right hand of the above equality x0 is equal to cos p theta upon q plus I, k is equal to 0, k is equal to 0, then sin p upon q into theta. x1 is equal to cos p theta upon q plus 2 pi p by q plus I sin p theta upon q plus 2 pi p by q x0 is equal to cos p by q theta plus I sin p by q theta. x1 is equal to cos p by q theta plus k pi p by q pi p by q plus I sin p by q theta plus 2 pi p by q and so on. xq minus 1 value cos p by q theta plus 2 q minus 1 pi p by q plus iota sin p by q theta plus 2 q minus 1 pi p by q. That is the two of the q set of value given by this equation are the same since the angle involved herein differ by less than 2 pi. The difference of the greatest and the least angle is p theta upon q plus 2 pi q minus 1 p by q minus p theta upon q, that is equal to, this is cancel, 2 pi q minus 1 p by q which is the less than multiple of 2 pi since q minus 1 less than q, hence the q value is given by 1 are distinct by giving to k the value q plus 1 q plus 2 we obtain no new value of the given expression and only the old value are repeated. Thus we see that cos theta plus I sin theta p by q to the power p by q, where p and q are integer prime to each other, has q and only q distinct value, and these are obtained successively putting k is equal to 0, 1, 2 dot q minus 1 in the expression cos p by q theta plus 2k pi plus I sin p by q theta plus 2 pi k. To show that the q distinct values of cos theta plus iota sin theta to the power p by q can be arranged in geometrical progression to show that the q distinct value of this can be arranged in geometrical progression, let cos p by q theta plus 2k pi plus I sin theta plus 2k pi into p by q. Then cos p by q theta plus I sin p by q theta cos 2k pi p by q plus iota sin 2k pi p by q. Then cos p by q theta plus iota sin p by q theta cos 2 pi p by q plus iota sin 2 pi p by q to the power k is equal to 0, 1, 2, q minus 1 terms. Then from this we obtain by putting k is equal to 0, 1, 2 dot dot k minus 1 the q distinct values as alpha beta, geometrical alpha beta square, alpha beta cube, alpha beta q minus 1, where alpha is equal to cos p by q theta plus I sin p by q theta, and beta is equal to cos 2 pi p by q plus I sin 2 pi p by q. We see that alpha not imaginary and beta is imaginary. Then alpha beta arranged, alpha beta square, alpha beta cube is in a geometrical progression. Example, prove that sin theta plus I cos theta to the power n is equal to cos n pi by 2 minus theta plus I sin n pi by 2 minus theta, and also show that one plus sin phi plus I cos phi divided by 1 plus sin phi minus I cos phi is equal to cos n pi by 2 minus n phi plus within sign minus I sin n pi by 2 minus n phi. Let sin theta plus I cos theta. The formula is this cos theta plus I sin theta, but here sin theta plus I cos theta, then cos pi by 2 minus theta plus I sin pi by 2 minus theta, because cos 90 minus theta is equal to sin theta and sin 90 minus theta is equal to cos theta. Then sin theta plus iota cos theta to the power n is equal to cos n pi by 2 minus theta plus I sin n pi by 2 minus theta. Equation number 1. Again, one plus sine phi, 1 plus sine phi plus I cos phi is equal to 1 can be written as sine square phi plus cos square phi plus sine phi plus I cos phi. Now this can be written as sine phi plus I cos phi into sine phi minus I cos phi plus sine phi plus I cos phi. Now we see that this term and this term common, then sine phi plus I cos phi within bracket sine phi minus I cos phi plus 1. Then 1 plus sine phi plus I cos phi divided by 1 plus sine phi minus I cos phi. Then 1 plus sine phi plus I cos phi will be found out sine phi plus I cos phi 1 plus sine phi minus I cos phi divided by 1 plus sine phi minus I cos phi. Then the power will be n, the power given by in the question to the power n, then we may write to the power n to the power n. This is the same, then cancel sine phi plus I cos phi to the power n. Sine phi we change cos and pi by 2 minus phi plus I sine and pi by 2 minus phi. Proof.